Welcome to our portfolio presentation of UML diagrams and artifacts. Our group consists of Evan Archambeault, a CIT major with a minor in management, and then myself, Nathaniel Ruminski, a CIT major with a minor in organizational leadership.
So first, we will review what has been accomplished for the course project. It consisted of a portfolio containing every SDLC essay, UML diagram, and comparison essays, which were equally divided up between myself and Nathan. Sticking with our group contract, we alternated tasks per week until the final project. For this presentation, it involves a summary of what is on the prior portfolio, explains briefly new topics not discussed within the course, and an overall reflection. So looking at the objectives for those presentations, we will first look at the methodology comparisons used in the portfolio. Second, we will review the diagram/artifact comparisons. Third, review the diagram and artifact limitations, along with provide new insights to other diagrams not discussed through the course. Fourth, conclude the overall class and project. And 5, have our final thoughts. Now we will compare methodologies. Looking at the SDLC methodologies, they contained a structured process to designing a system which includes planning, analysis, design, implementation, testing, and maintenance. An example of an SDLC method is the waterfall model. This is a linear approach where one step of the process must be completed before the next step can begin. In contrast, object-oriented methodologies focus on being able to represent a system as a series of interacting objects. They emphasize the flexibility aspect that the SDLC methodology lacks by not having a linear process. An example of object-oriented process is the unified process, which is iterative and incremental. Overall, SDLC methodologies provide a structured format with clear phases, while object-oriented phases allow for more continuous improvement along the developing process.
We will now move on to some comparisons between all of the diagrams. All of the diagrams contain a high-level understanding of the system. All diagrams trace back to previous requirements, and all diagrams feed into later stages of development. Some big differences are that each diagram shows a different aspect of the system, and each diagram uses a different modeling style.
Every UML model has their own impact on the overall SDLC, meaning that if one were removed or incomplete, complications arise. We will look at a small scope of 3 examples to prove this case. The use case diagram is used to show how system components interact in various ways. Without the use case diagram, many, if not all, stakeholders' needs will be missed and not carried out throughout the SDLC, ruining future diagrams, the system itself, and the relationship with the stakeholders. Next, the sequence diagram is used to represent the interactions between objects of the system in a sequential order. It is considered a high-level view of system functionality, so without it, system designers and developers cannot understand how components communicate, which leads to confusion about system functionality and missed requirements. Finally, the class diagram demonstrates all classes within the system by defining their attributes, methods, and relationships. Without the class diagram, developers have no clue how data should be structured within the system, causing inconsistencies and potentially data duplication. All of these issues end up degrading the system structure and performance, which lead to more inconsistencies with the next steps in the SDLC.
On this slide, we are showing 2 different UML diagrams to showcase the limitations that come with each modeling style. On the left is a use case diagram, and on the right is a class diagram. Starting with the use case diagram, its strength is that it gives us a clear picture of how different actors interact with our system. However, its limitation is that it's very high level and it doesn't show us what happens within the system at all. On the other hand, the class diagram goes much deeper. It shows the structure and relationships between the objects, which is very useful. But its limitation is the fact that it can become too detailed very quickly. So together, both diagrams show that every modeling approach has trade-offs. And in these 2 diagrams cases, one gives clarity at a high level while lacking depth, whereas the other gives depth but can lose you on what the bigger picture really is.
So now we will briefly discuss some diagrams that are not taught in the course material. The first diagram we will look at is the interaction overview diagram. It is considered a behavioral diagram at a high-level view. It shows the flow of interactions between different elements within a system. When specific interactions occur, this is demonstrated through various branches and decisions. Looking at the diagram at the bottom, you are able to see how elements are connected, also known as interactions. More than one of them are connected to several other elements. The concept may seem similar to the sequence diagram. However, the interaction overview diagram shows the flow between multiple interactions, whereas the sequence diagram shows the messages between different objects within one specific interaction over a period of time.
The second diagram we will look at is the package diagram. This is a structural diagram that organizes similar classes into one package. It is an organized way of visually representing dependencies and relationships between packages. The package diagram helps to manage complexity in larger systems as it organizes the system into smaller sections to handle more at once. To almost wrap everything up, we want to highlight the key takeaways from this project. First, we looked at the differences between SDLC and object-oriented methodologies, as it's clear that each one fits specific scenarios. SDLC models give us more step-by-step processes, while object-oriented focuses more on the objects and the interactions they have. Understanding the right choice is crucial for proper development. Next, the diagram comparison showed us how each type of diagram gives us different views of a system. All provide a high-level view, but some might go a little bit more in depth with their view. Together, they allow us to understand the system from different points of view. Finally, we looked at the limitations that each diagram might face. Each one has its strengths and weaknesses, but all of them are necessary for proper system design. Using them together allows us to get the full picture of a system. Overall, these insights truly help us understand how important it is to choose the right methodology and diagrams depending on what stage of development you are at.
Overall, this course has been insightful as it has gone further in depth compared to prior classes about systems analysis and design. Using a real life case study allows students to make connections to actual organization scenarios. By learning through the course material, students are able to translate those skills into a technical design to demonstrate this understanding. Designing a portfolio and presentation about the systems development lifecycle allows students to express their understanding about the practical topic for future reference. For example, students may bring up these sort of projects within an interview process. We would recommend taking the course if you are interested in or passionate about designing different types of systems.
This slide gives our references and credits for any information that we use throughout the presentation. Thank you for listening and going through the project with us. We appreciate the opportunity to walk through our work and share the concepts that we have learned throughout this class.